Okay, now we're on question number 2.2, which in your packet is still on page 2, and it's just right there. And it's going to follow the same four fraction kind of thing, and the only difference here is we're going to be talking about grams from grams instead of we referred to grams in the previous question. Okay, so it says how many grams of liquid water are made from 29 grams of oxygen gas at STP. Alright, so here's our balanced equation. Alright, and apparently we're not even going to be concerned with hydrogen gas because the question is talking about liquid water, so we're going to be concerned about this, and oxygen gas will be concerned about this. Right, and we know there's going to have a little invisible one there, right? It's a balanced equation. 4 hydrogens, 2 oxygens, 2 oxygens, right? Alright, so at this point we go, how many grams of water? So that's our unknown. So grams of H2O, okay? And remember our little gun thing. If I kind of draw this, then I'm going to remember this is 1 mole of H2O, and this is moles of H2O, okay? And we're going to do there. Remember, this fraction, the third fraction here, it's going to use the coefficients of the balanced equation. All right, so we already know that 2 is there. Now, grams of H2O, that means molar mass of H2O. So if we look on our molar mass paper, H2O has a molar mass of 18. Okay, so we put an 18 in that spot. Okay, all right. And our known is 29 grams of oxygen gas. So 29 grams of oxygen gas. Okay, and so here again, here's our brush. Here's the bristles of the brush, and here's the handle of the brush. And so now we need to put grams is on top there. We need grams down here of O2, and we're going to convert 29. That looks like a G there. 29 grams to moles. Okay, so we need oxygen's O2's molar mass. So we look on here, and oxygen's molar mass is 32. So that's the number we're going to put right here. 32 grams of O2 is equal to 1 mole. All right, and then we need to put here the coefficient, which in this case is 1. Right. All right, and so now we're ready to punch them in the calculator. So we would go 29 times 1 times 2 times 18, and then we're at the end of the numerators, so now we're going to do all our denominators. All right, divided by 32 equals. Okay, so then we punch that into the calculator. Oops. And clear it. 29 times 2 times 18 divided by 32 equals. So our answer is 32.625, and really since we had two significant figures here, we would like to round that to 33. Okay, so 33 grams of H2O could be made from 29 grams of O2. Okay, and that's how we do number 2.2. Okay, now we're ready to do question number 2.3, which is still on page 2 of your packet. It's located right here. It's asking how many liters of NH3 can be made from 56.2 liters of N2 gas at STP. And remember, all this estimates is that whoever was doing this experiment would be at sea level at 0 degrees Celsius, and because that's the standard temperature pressure that gases are, well, this definition of 22.4 liters is 1 mole. That's only true at STP, at 0 degrees Celsius at sea level. Okay, so how many liters of NH3? So we're going to go liters of NH3 here, and of course that's our unknown, so we put it here, liters of NH3. Okay, and by the way, NH3 is common, it's common. Okay, and if we remember our little gun thing, we know this is NH3, this is NH3. So I can go ahead and put my 2 here from the balanced equation, right? Alright, my known is 56.2 liters of N2 gas. So 56.2 liters of N2, and I'm just going to put it here. Alright, and here's my brush. the handle of the brush. Okay, and so since liters is on top here, I want liters on the bottom here, and this is of an N2 gas. And we know that at STP, 1 mole of a gas is 22.4 liters. Okay, and the coefficient in front of N2 is a 1. So I put that there. Alright, oh, I forgot to finish this up. We know that 1 mole of a gas, and it says, well, it didn't say it was a gas, but ammonia is a gas, that would also be 22.4 liters. Okay, so when you kind of look it over, it's like, well, goodness, we've got 22.4 liters on top, we've got 22.4 liters on the bottom. So really, you're just going to be basically going 56.2 liters times 1 times 2 times 22.4, oops, and then divided by 22.4 equals, right? This 22.4 is that one there. So a lot of times people will just kind of say those cancel each other out. Liters cross each other out. Mole, 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 mole. Oops. This liter didn't actually cancel out right here. The number 22.4 did, but not the unit liter. Okay? And so when you punch it into the calculator, you're just basically going 56.2 times 2, which 56.2 times 2 equals 112.4. Since we have 3 sig figs here, we want to round that to 112 liters of ammonia gas. So 112 liters of ammonia gas can be made from 56.2 liters of nitrogen gas. Okay, this next question, 2.4, is still on page 2 of your Stoichiometry Chapter 9 notes, and it's located right there. It says, how many grams of H2? So grams of H2 is our unknown, are needed to produce 93.3 liters of NH3. So this is our known, 93.3 liters of NH3. Okay, and I want to go ahead and do my brush. There's my brush. Here's the handle of the brush and the bristles of the brush. Okay, and then I'm going to do my gun. Here's my gun. Okay, and since liters is on top here, I'm going to want liters on the bottom here. I want liters of NH3 gas, which moles is 93.3 liters. So the number here at STP is 22.4. Okay, and this number is going to be the coefficient, right, of NH3, because NH3 is, so that's a 2. All right. Okay, and now I need grams of hydrogen, and probably you have that down in your memory, that the molar mass of hydrogen, H2, is 2. Okay, and then the number in front of H2 is a 3, so the 3 goes there. Okay, so then I'm ready to punch it in my calculator. It'd be 93.3 times 3 times 2 divided by 22.4 divided by 2 equals. So when I punch that in the calculator, 93.3 times 3 times 2 divided by 22.4 divided by 2 equals 12.49. Okay, and then I've got 3 sigs here, so I want to round that to 12.5.